All right, let's get right into it. Every single time you stream a movie, hop on a video call, or even just scroll through your phone, you are tapping into an incredibly complex, high-capacity system. Today, we're going to pull back the curtain on the secret superhighway that makes our digital world possible, WDM and its big brother, DWDM. But first, you got to understand the problem we were facing. See, our world today runs on data, and we're creating and consuming it at a rate that is just, well, it's staggering. This created a huge challenge. How on earth do we move all that information around the globe in the blink of an eye? Which brings us to this really fascinating question. How can these tiny fiber optic cables, many of them no thicker than a human hair, possibly handle the weight of our entire digital lives? I mean, it sounds like some kind of magic, right? But it's not magic. It's just some seriously brilliant engineering. And this data explosion, it's coming at us from all sides. It's the 4K movies we stream on demand. It's the millions and millions of smart devices in the Internet of Things all chatting with each other. And of course, the enormous demands of AI. All of this puts a crazy amount of pressure on our global networks. So how do you solve a crisis like that? Well, the first part of the answer started with this revolutionary idea. What if we could send more than one signal down a single fiber optic cable at the same time? And that, my friends, is where WDM comes into the picture. You see, the core idea behind wavelength division multiplexing, or WDM, is actually beautifully simple. Light comes in different colors, right? Different wavelengths. So the thinking was, why not just assign a different stream of data to each color? Then you can mush all those colors into a single beam of light, shoot it down the fiber, and just separate them out on the other end. Here's the best way to think about it. Before WDM, a fiber optic cable was basically a single-lane road. You could only send one car, or one data stream at a time. WDM came along and essentially painted a bunch of new lanes onto that road, letting all these different streams of traffic flow at the same time, without ever crashing into each other. The process itself is like a simple three-step dance. First, a little device called a multiplexer acts like an on-ramp, merging all those different colors of light together onto the one fiber. Then, that combined light travels, sometimes for thousands of miles. And finally, a demultiplexer acts as the off-ramp, splitting the light back into its original colors, each one carrying its own unique data. Simple as that. Now, WDM was a total game changer. But our demand for data just kept exploding. Engineers needed to figure out how to get even more lanes on that highway. The solution wasn't to build a wider road, it was to pack the lanes incredibly close together. And that is where DWDM enters the story. The key is right there in the name, dense. Dense wavelength division multiplexing takes that same WDM idea and just cranks it up to 11. It uses unbelievably precise lasers and filters to slice the most efficient part of the light spectrum into these razor-thin channels, squeezing a massive number of them into the exact same single fiber. So let's go back to our analogy. If WDM turned a single road into, say, a 4-lane highway, then DWDM basically turned it into a massive, futuristic, multi-level superhighway with dozens and dozens of lanes all stacked on top of each other, moving at the speed of light. It's a whole other level. And the scale we're talking about here is just mind-boggling. We're not talking about 4 or 8 channels. Nope. A pretty standard DWDM system can support 80 channels or sometimes even more. And get this, each one of those channels can carry data at 10, 40, or even 100 gigabits per second. It's a truly exponential jump in capacity. The capacity isn't just a little bigger. It's in a completely different universe. We're talking about terabits per second. Now, to put that into perspective for you, 1 terabit is 1,000,000 megabits. That's enough capacity to transmit the entire text of the Library of Congress in just a few seconds. That's the kind of power we're dealing with. Okay, so we've got these two powerful technologies, but how do they really stack up against each other? Let's do a little side-by-side breakdown to really see the key differences and understand when you'd use one over the other. You know, when you boil it all down, the difference is actually pretty straightforward. WDM uses fewer channels, and they're spaced farther apart. It's simpler, it's cheaper. DWDM, on the other hand, is all about that density, a huge number of channels packed incredibly close together for the absolute maximum capacity. The details in this chart really tell the whole story. Just look at the channel spacing. DWDM channels can be just 0.8 nanometers apart. That's an insane level of precision. And it's what allows for so many more channels and that massive capacity. And that also explains where they're used, right?
WDM is great for shorter distances, like within a city. But DWDM, that's the powerhouse you need for the long haul, global backbone of the entire internet.
So why should you care about all this technical jargon? Well, because this isn't just some abstract technology in a lab. It is the invisible, foundational infrastructure that powers pretty much everything you do in your digital life.
I mean, just think about the services you use every single day. The cloud, where all your photos are stored, connected by DWDM. The data centers running your favorite apps, you guessed it, DWDM. The ability to stream a 4K movie without it buffering or have a crystal clear video call with someone on the other side of the planet, that is all made possible by the unbelievable capacity of DWDM networks.
This really gets to the heart of it. As one source put it so well, DWDM is not just a technological advancement, but a necessity for modern telecommunication. We're at a point now where this isn't just about faster downloads. This is the absolute foundation for entire trillion-dollar industries, from global finance to e-commerce to cloud computing. So the next time you effortlessly pull up information from halfway around the world, just take a second to remember that silent, invisible engine working behind the scenes. A whole rainbow of light packed into a multi-level superhighway racing through a single tiny strand of glass to make it all happen. We have managed to push the absolute boundaries of physics to meet our seemingly infinite demand for more and more data. But as that demand just keeps growing, you have to wonder, how much more can we possibly squeeze out of a single beam of light? And what in the world comes next?